and today we'll be talking about zero trust. We'll be discovering what it takes to implement a zero trust architecture. We'll be showcasing what standards help secure zero trust in a token-based architecture, and we're going to be highlighting the gateways necessary to implement zero trust access for APIs and microservices. But first, I thought I'd look into what exactly do we mean by zero trust? Well, nowadays, the traditional perimeter of a corporate network is sort of dissolving. This is happening because many more resources are being moved to the cloud. Secondly, is the rise of remote work and distributed teams. Lastly, devices are much more distributed than they were in the past. And what all this means is that the traditional model of placing security at the perimeter is now somewhat antiquated, as it doesn't block hackers that might be posing as an internal user. So zero trust is a response to all this new reality. It means taking a trust no one, verify always approach by assuming every caller to a service is a potential threat, regardless of whether it's coming from inside or outside the network. Zero trust is more of a philosophy rather than a single particular product or service. As such, there are many tools and strategies to implement a zero trust architecture. But in general, a zero trust approach will always verify that an entity requesting access to a record has the permissions to access it. This must be processed for both users and microservices, and will likely involve attribute or policy-based access control systems for each service or workload. So what are some benefits of adopting zero trust? Well, things are so connected and residing in the cloud nowadays, as I said previously. Plus, many types of users might be accessing a single resource, whether it's internal teams, remote workers, contractors, partners, or public end users. And with the rising number of vulnerabilities and exploits, a zero trust strategy is arguably a necessary response to all these modern software risks. By building for zero trust, you can help protect personally identifiable information. Hunkering down access to this is especially important in areas that carry sensitive data, like healthcare, financial institutions, or government. So I've given a pretty cursory overview of what zero trust is and its benefits. And today we're going to dive far more deeper into this. And we've brought two experts in who both have a lot of knowledge in this field. First up, we'll be featuring Jonas Iggbom, Director of Sales Engineering at Curity, who will be explaining why a token-based architecture aligns perfectly with a zero trust model. After that, Keith Casey, Product and Go-to-Market at ngrok, will tease apart some of those misassumptions around zero trust in the market and hopefully extract some principles we can use to improve our security. So for those of you tuning in live, please write in your questions in the chat throughout the event, and we'll try to take them all in the Q&A after these two presentations. So thanks a lot for being with us, Jonas, and feel free to take it away whenever you're ready.
All right, thanks, Bill. So as Bill mentioned, I'm Jonas Iggbom. I've been at Curity for about 2 years almost, where I, for the most part, deal with technical pre-sales, but I'm also doubling into what we call the product market engineering team on occasion. So some of you, if you've ever visited our resources on our website, you might recognize my voice. I've done some of the recordings and articles and whatnot there as well. So Bill sort of prefaced the agenda a little bit here, but I'll start diving into what we need for identity when we talk about zero trust. It's obviously sort of a key part. Authentication is usually something that's needed in this, right? We need to be able to know who the user is. And that kind of prefaced the token-based architecture a little bit, where we are going to take a look at tokens and what scopes and claims do with tokens or in tokens. I'll briefly cover a little bit what we call the phantom token pattern. It's relevant in the zero trust architecture, but it's a powerful token for especially for privacy and leaking PII information, for example, as well as an entitlement management system, or an EMS, which is a core part or a key part that could help a lot in this architecture as well. So Bill already sort of mentioned this phrase. I've seen it a lot. There's no surprise in that we see it. Never trust, always verify. It comes from sort of NIST's paper on zero trust. But that is, I mean, if you take it down to one sentence or one phrase, it's essentially what zero trust is. Never trust, always verify. And obviously, this puts sort of the identity at the perimeter instead of the traditional network-based perimeter approach that we have seen so much in history. But to verify who the user is, and then after that start determining what access they should have or what they should have access to, we definitely need to authenticate, right? We need to understand who the user is. So at the core of this never trust, always verify is essentially to understand the identity of who or what is trying to gain access, right? And this is aligning extremely well with the token-based architecture. As a token-based architecture, you know, from a higher level perspective, you essentially use the token to identify yourself. There's something that's issuing the token that has identified who the user is, if there's a user, or who the system or API is. But then you leverage that token to authenticate yourself throughout the environment. And if we look at authentication specifically, there's obviously a lot of aspects that goes into authentication, but we have probably all heard passwordless lately. This is something that's for sure gaining traction. There's a lot of different ways of doing passwordless authentication these days, but it fits well into the zero trust approach, where you on a regular basis have to verify the user. I mean, imagine if you didn't have passwordless, and imagine that you didn't have a token that you can use to sort of authenticate yourself. You would pretty much need to authenticate all day, every day. Every time you try to do something, you'd probably have to authenticate if you think about it that way. So passwordless is gaining traction from that perspective. It's gaining traction from simplicity and from quite honestly, a lot of the passwordless options are better than a password, right? Because passwords get breached and leaked and then reused. And if you have a strong passwordless option, it's many times better sometimes than an actual password. But you can also move into the single sign-on, or something that we see gaining traction also, which is sort of, I guess, a hybrid between authentication, single sign-on, and passwordless, which could be what we could call reduced sign-on. So it's a way of simplifying the authentication and reducing the number of times you do have to sign on. This is something where we can, I think, see WebAuthn, for example, as an option. I don't know. Sometimes I feel a little bit torn between, is that truly passwordless or is it reduced sign-on? But WebAuthn is a strong authentication mechanism that can definitely be leveraged there. There's also, obviously, we at Curity at least hear a lot of requests or requirements when we talk to organizations that they need to implement multi-factor authentication. And there's a lot of options here too, but something to consider there is when you need multi-factor authentication. There's a strong sort of approach for doing what's called step-up multi-factor authentication. So you can require multi-factor authentication for critical resources rather than everywhere when you authenticate, for example. And so you might be authenticated with one factor, you might have single sign-on with that factor, but when you try to I don't know, in a financial setting, you try to approve a transaction, for example, that's when the second factor or additional factors kick in for authentication. There's also the notion of leveraging geolocation data for stronger verification of the identity. There's things like, you know, logging in from a net new location, or if you performed an impossible journey, as it's many times called, meaning I logged in from one location and now I'm logging in from a different location, but it's practically impossible for me to travel between those two locations that fast. Obviously, that can be impacted by the likes of VPN that thinks I'm in a different location than where I am, but this should be viewed as sort of an input, a risk score, if you want to call it that, to determine should we or do we need to authenticate this to really verify who this user is, for example. And then last, in my slide here, continuous authentication is the sort of concept of always authenticating the user in the background when they're using the system, for example. There's some cool technologies. I don't think they're super highly adopted yet, but they're technologies that can determine your essentially a profile of you based on your keystrokes on the keyboard or how you move the mouse on the computer. And if it's detected that it is not you, it will essentially kick you out or log you out, or maybe that's when we trigger an additional stronger factor for authentication. So once we've got authentication out of the way, we've sort of determined who the user is or who the system or what the system is. That's when sort of more the token-based architecture takes over. Tokens in themselves are essentially a convenient way to transport this attribute data. We'll get into that in a little bit here, but that attribute data is typically transported in token as claims. Tokens are issued differently. So, you know, one client application will get a token that looks in one way, and different other applications will get different tokens. You get sort of a token that's bound to the specific application or the API or what have you. So it's not just that you issue the same token for all types of applications and APIs. They're typically bound to the specific use case there. And then there's obviously different types of tokens. The more common ones, at least that we see here at Curity, would be the two first here: an opaque token, which is also referred to as a reference token. It's essentially just a string that doesn't really mean anything. I'll get into more on that topic when I talk a little bit about the phantom token pattern. The next token that usually everyone's familiar with is a JSON web token, or a JOT in short, which is what we typically see holds a lot of this data and information, and can be very powerful because they can be, you know, self-contained, and they can be verified without calling an authorization server that has issued the token, for example. So within the token, we hold something called claims. So a claim is essentially an assertion that can allow the API or the application that's going to consume the token to trust the information that's the value essentially that the claim holds. So if you have a token that contains the subject Alice and the role teller in the region California, that essentially means that, and if Curity has issued a token, it essentially means that Curity asserts that Alice is a teller in California. And with, for example, a JOT, you can typically verify the information, or verify the token itself. You can check the signature to see if the token has been tampered with or whatnot. So you have a high level of trust in that information in there. Claims also allow the user to consent what information or data about themselves or other information that's shared with the application of the API. So we've all probably seen when we log in using, for example, Google, you get that pop-up screen with some checkboxes, and it asks like, are you okay sharing your email address, your phone number, or whatever it might be with whoever you're sort of logging in towards. So claims within the token, there's not only claims that we put into the token, right? So there's standard claims as well. So as part of a claims-based authorization model and in a token-based architecture, there's a lot of things we can use the claims for, but the audience claim odd claim is a powerful one. It holds the information. Remember, I said in a little while ago here that tokens are bound to their application. This is essentially the audience. So you can use the audience claim to check, is this token actually intended for this API that is trying to be accessed, or is it intended for something else? So that's one part. We can leverage custom claims like that role or region that I mentioned to also determine further, should this user or system have access to this API that they're trying to get to. And then you can, there's a lot of different sort of places along the way, and this is probably something that Keith will cover a lot more, but there's a lot of places along the way to the API that you can check the token and the claims in the token to verify should access be given, because it's not sort of coarse grained, right? It's not necessarily yes, you get access to the API or not. It could be, yeah, you get access to this API, but you can only perform a GET request, and you can only access parts of the resource that you're trying to get to. So we're getting sort of into finer grained access control. And when it comes to APIs, you might have sort of a deep structure in the API as well. An API calls another API that calls another API. There's some inherent risks with that if subsequent APIs are third-party APIs, for example. But this is where the claims-based authorization comes in, and you can check this along the way to prevent deeper access into the structure where you shouldn't have access in sort of subsequent APIs that are called. I'm sure scopes is a familiar term. Scopes are essentially a grouping of these claims that we just talked about here. So it actually represents a sort of a scopes of access. So if you look at that definition, this is where we kind of define access. And there's different ways to structure scopes, but typically you kind of request one or more scopes, and that results in a set of claims that are associated with those scopes to be issued into the token. Now, scopes are great, but they can also lead to, we've all heard the term role explosion, where you end up having more roles than users. There's actually a term that's called scope explosion too. So you could end up a situation where you end up having a lot of scopes that are really hard to manage. Claims are better from that perspective to scale an environment in itself. But scopes is sort of it's what we use to request what claims and that are issued in the token. One of the most sort of, I wouldn't call it famous, but known scopes probably is the OpenID scope that will then trigger that you get issued an ID token in the most cases. Just popped in an example of a token here. This is decoded JOT essentially. So we can see here there's an issuer that sort of denotes who issued the token itself. There's a token type, client ID, audience, like I mentioned before, and then obviously you have things like expiration. These are all things that get sort of checked along the way, right? There's no need to forward this token to an API if it goes through an API gateway, if the token is already expired. So different claims in this token can be used to go from a coarser grained authorization and checking if access should be allowed to more and more finer grained, right? And a lot of the data in a token, if we think about sort of starting populating this token with information about the user, right, is could be PII information. So we don't really want that information to be available externally or publicly, right? So if we look at an architecture like this, we can leverage something called the phantom token pattern. And the idea here is that the token service externally to the application issues an opaque token or one of those reference tokens. It's essentially just a randomized string, which is globally unique. And then when we get to when we try to access the API and we hit sort of the API proxy or gateway or whatever it is in between the application and the API, there's typically something there. We make the proxy there exchange the opaque token for an actual job that's more richer and has the information, right? So what we can do here, and it can be verified. So we essentially make an introspection call to the token service, and in replacement for the opaque token, we get a jot. And now the jot can be passed on to the upstream API and consumed by the API, because it's typically the API that needs the information here, that needs to consume the jot. The application on the outside is sort of shouldn't really be involved in reading that information or even needing it necessarily. Of course, there's sort of corner cases, and corner cases can be handled. You can issue different types of tokens. You could issue a jot to a public to one application, but an opaque token to something else. You can also leverage something. You can also leverage the notion of wrapping a token inside of another token. So there are ways to get some bits and pieces of information to that public application as well, if needed for some corner cases. The token service is pretty good at handling sort of how a token is issued, but there's also a growing need in this architecture for an entitlement management system. And this is typically what when you mention fine-grained access control, externalized access control, or attribute-based access control, or policy-based access control, are all sort of the same thing with a different name. This is where an external system can hold a policy that determines and denotes access control rules, right? And this can be used in a lot of different ways. It could be used by the identity management system or the token service, because the token service could essentially call this external entity to determine what claims am I allowed to issue into this token. But it can also be consumed, or it can also be used by the API management system, gateway proxy, to pass on the jot to this external entitlement management system, and that policy in that location then determines what access should be given to the API, which could be things like finer grain in the sense that you can only access records that you own, meaning that then you have sort of a dependency or a relationship between the subject, the user, and the record that you're trying to access. In EMS systems, there's a bunch of different components. I'm not going to cover all of these, but there's typically something that is the actual sort of policy engine. It's typically referred to as a policy decision point, or PDP. And then we have something to author policies, which is the policy administration point. But in the end, it has to be something that enforces the policy, right? So that's the policy enforcement point. That's the part that can take a lot of different shapes and forms, and it's what typically fits really well with the proxy or API gateway that's sitting in front of the API itself. I threw in some of the frameworks or standards here, but the more common ones used for this would probably be XACML and Open Policy Agent has gained a lot of traction the last, say. So this then changes not not entirely, but slightly. We have sort of the issuing of the token could then, in that step, could then make a call out to an EMS PDP to determine what claims am I allowed to issue in this token. Token is issued, it's passed on to the API proxy gateway that acts as a policy enforcement point there. And the proxy can then forward, at least for open policy agent for sure, you can pass on the entire JOT. An open policy agent within the policy language there can actually decode the JOT and verify it, and then respond with a decision back to the gateway that denotes what access is allowed or not, essentially. So you're gating this control earlier in the architecture rather than having the API itself make the decision as well. So obviously the proxy here can also make a lot of decisions already based on, is the token expired or what have you. So coarser grained authorization there. So in sort of wrapping that up and handing it over to Keith to kind of move this forward, Zero Trust matches and aligns extremely well with the token-based architecture, where a token can be passed around as sort of the authentication mechanism, but meaning the identity is essentially the new perimeter versus sort of the network perimeter that we've seen in the past. We can leverage claims-based authorization to provide a finer grained authorization throughout the architecture. We want to prevent PII information in public clients as much as we can. Sometimes it's not possible, but this is where that phantom token pattern comes in. There are other patterns, like for example, a split token pattern that can be leveraged there as well. And then with this, you want to see a multi-layered authorization approach where you can have multiple layers of sort of from coarser to finer grained authorization within this environment and this architecture. And then with that, you need something to gate that, right? Which is also the zero trust approach of sort of always verifying. You need something to gate and to check that identity, at least in front of the API, which is where an API gateway or a proxy takes over and fits extremely well. And with that, I'll hand over the baton to Keith.
Awesome. Thank you, Jonas. A lot of great information right there. And looks like we're getting some questions in too, which we'll take after this next presentation. Yeah, Keith, take it away.
Cool.
All right, brilliant. Thank you, everyone. So let's see. I've got some bad news to open with for everyone. Turns out zero trust is not zero effort. There's a lot of work. There's a lot of thought that goes into it. So Jonas covered some fantastic details in terms of like some of the implementation things, especially with the tokens and passing around and what you can do with it. I'm going to move out one level, a little bit more abstract, and talk about sort of the level of effort involved. And unfortunately, it's not zero. So that our rough agenda, I'll do a brief intro on myself. We're going to go back to basics, understanding what those core principles are. We think we understand them, but I will throw out the idea that we're applying them in not quite the right places, that we're applying them at the application level, and we're thinking about things not in quite the correct way. And part of that is because the risks we're actually addressing. We think we're addressing one set of risks, and those are important to address, but there's a deeper, more visceral layer of risks that we need to think about, and we need to figure out how we're going to approach them. So sure enough, we're going to lay out an approach, and then I'll go ahead and close and hand it back to Bill at the end here. So a little bit about who I am. The genesis of this presentation comes from a lot of my sort of philosophical approach to things. If you rewind 15 years ago, I had a career hypothesis, an industry hypothesis that the ecosystem that we work in, tech as a whole, is only getting better by most measures. Processing is getting cheaper, storage is getting cheaper, communications, it's only getting more ubiquitous and faster as we go. Security is a mess, but we'll come to that in a minute. But when we have this distributed architecture architecture, this distributed power generation, storage, processing, communications, all these different things, we have to look at the world differently. So about 15 years ago, I shifted my thinking, and that really defined my career after that. I joined a little company called Twilio at the time. I say Twilio was little because I was employee number 20, 22, somewhere right in there, because part of my reasoning for joining there was that as these components are becoming more distributed, they're going to have to speak to one another. They're going to have to interact. So not surprisingly, I fully believed then and still believe now, APIs are going to be the way that happens. After I left Twilio, I went over to a company called Okta, worked on their OAuth as a service product, because once those services and those systems start interacting, they're going to need to interact securely. They're going to be able to validate each other's identity, their credentials, their information, the token-based architecture that Jonas is just talking about. And then you move up one layer to my current job at ngrok. ngrok, fundamentally, we are a way of being able to securely tunnel between your system to the rest of the world. And your system could be that system sitting on my desk right here in front of us. It could be something living deep in the bowels of your data center. It could be that IoT device living on a customer site. So when you bring these three things together, you end up with the APIs to have things communicate, the security layer to make sure that they communicate securely, and then the actual connectivity layer to make sure they can communicate. So when we go back to that career hypothesis, obviously it maps really well to zero trust. We have all these components, all these systems, all these devices all over the world trying to communicate with each other securely. And frankly, it turns into a big hairy mess, but we'll get into that in a minute. Obviously, this maps very nicely to zero trust. I didn't really understand that concept when I started, but it really wasn't a concept then. So when we go back to the basics, I like thinking of it from, we know our three principles. Bill talked about at the beginning. We need to have continuous verification. We need to understand what is the identity, what is the context of what's going on here with this connection, with this request, with this action that system requesting of system B, or that user A is requesting a system B. Next up, when there's an issue, because there's going to be an issue, as hard as we work, as deep as we go, there's going to be problems that pop up. There's always going to be some system goes offline, some bad actor gets access to things. We want to be able to minimize the impact. Now, this isn't absolving us of the responsibility of securing these things. We can't go that far, but we need to say that sometimes systems will be compromised. Sometimes systems will go offline. We need to make sure that it doesn't take down our entire architecture as a result. And finally, collecting using the context. This is one of those places where we expect machine learning, we expect AIs, we expect all these other really cool acronyms to save us. Frankly, for the most part, we do not have the right data. We have these massive piles of data that isn't sorted, that isn't organized, isn't categorized. If you look at any security operations center and you look at the sheer volume of flags, of issues, of warnings going off, frankly, it's mind-boggling and it's distracting. So I suspect we're doing that wrong too. I'm not going to dive into that here, but we really need to get back to these principles and understand how they fit together. And I think part of the reason why we're not doing this well as an industry, I'm not pointing at any one of you in particular, I think one of the reasons we're not doing this well as an industry is because we're looking at the wrong layer. When we look at the OSI model for network communications, architecture, how these things communicate, most of us are software developers. So we love this top layer. We love thinking about how are our applications secure. When I started my career, it was all about, filter input, escape output. That is absolutely the very top two layers at most. We need to understand how our application is interacting with things and how the data is presented. That was a good start. That is nowhere close to what we need to figure out here. When we get deeper, we need to figure out how we're addressing things. And at that point, we leave out a lot of assumptions about the underlying network. We don't think about how it's connecting, how it's working together, how it's doing what it's supposed to do. I always had one fun thing when I was with Okta, we were on a customer site. This was about 5 years ago now. And we're helping them secure their API with OAuth. It was a great, fun experience. And we went on site with them, and they'd passed me their API design docs many times. And I was offering some feedback and asking some questions. It was a great conversation. And when we went on site with them, I realized I was wondering, could I connect to their API? What could I do? So I fired up Postman, and I went ahead, pulled up the API docs that they'd already given me that weren't, access wasn't available outside their firewall. And I went ahead and started making requests. And they were successful. So about an hour or so into the meeting, I turned to one of the people on their side, one of the network architects I'd know, or security architects I'd known for probably a year or so at that point. And I said, hey, if somebody was using your API and they hit this error, how would they resolve that? And he says, oh, well, it's probably something like this. You would do this, da, da, da. And I said, okay. I went back in the Postman, fixed my error, and continued on. About 20 seconds later, he turns and looks at me and he says, why are you asking that? And I said, oh, well, because I'm connected to your API right now. I turned my machine around. I said, here's a request that I just did. He was not very happy. Not just with me. He was very unhappy with me, but he was also unhappy with how in the world is this happening? When we dug into some of the root cause of what happened here, well, at some point, when they were designing the API, when they were putting together that authorization layer, they had a security assumption that anyone on the network was authorized. Yeah, you're starting to see the problem here. Then the office facilities people went to a flexible office environment. So they got rid of hard connections and authenticating to everything, to network resources. And they opened up the network, and they started a guest network, and they had Wi-Fi deployed everywhere, and people carried their machines around. And then at some point, the guest network got merged with the corporate network. And so me, an idiot on the guest network, was able to connect to their production APIs, was simply looking through their API docs. This happened because the API security folks had assumptions on how the network underneath them would behave and what constraints and security policies were put in place there. And it turns out those assumptions were correct at the time, but they were never clearly documented. They were never communicated to everyone else. And so those security assumptions, as they became false over time, now suddenly their entire security architecture fell apart. And we don't know exactly when that happened. There was a concrete date for when people went to a flexible office environment, but there was no concrete date of when people didn't have to authenticate anymore. Most likely the developers noticed it at some point, didn't think anything of it because, well, I'm an employee, I probably have access, and just continued on with their day. These are the kind of things we need to think about. When we're securing our applications and the APIs underneath them, we need to think about the communications layer, the network underneath that. How are we securing it? Is it secure? How much can we trust it? And the short answer is we can't trust it, because as much as we want to think the world looks like this, that everything is neat and orderly and predictable and beautiful and wonderful and all that, come on. We know in reality it looks nothing like that. We know in reality that it's a big, hairy mess, and there's assumptions, there's patches, there's problems baked in to every single layer that are kind of glossed over, and people are hoping that this time it works. So I'm sorry if I'm bursting your bubbles first thing in the morning. That's kind of a rough way to start the day. But fundamentally, I want to make sure that we are building secure systems. Back to that career hypothesis. As more data is moving across our networks, as more processing is moving from A to B, as more things are stored, as power is generated and stored in different places, we need to know that the systems that we're relying on are as secure as they can be, and that we're not counting on them being secure. So even if something is compromised, even if something is a complete and hairy mess, our stuff is still going to be okay. That's a hard world to navigate, but it is our world. Jonas cited the whole thing about the perimeter is being dissolved. Yes, absolutely. We saw this prior to COVID pretty strongly with remote work and the cloud and all that stuff. But with COVID, come on, there is no perimeter anymore. The assumptions we had, the assumptions that we based our entire architectures on are gone. The sooner we acknowledge that, the sooner we accept that, the better off we're going to be, and the better decisions we're going to make going forward. So with that, let's talk about the actual risks we're addressing, and then we could talk about some approaches on how to do that. So when we think about what risks zero trust are trying to counter, obviously we have insiders. If you look at in the States, the FBI reports something about, I believe it's 75 to 80% of breaches are caused by insiders. Now, some of those might be stolen credentials or misused credentials inside the network. Fundamentally, it doesn't matter. Just because somebody has credentials that are valid and valid at that time of authentication doesn't mean anything. We can't count on that at all. We need to understand that insiders are compromised in some way. Maybe it's malicious, maybe it's just bad luck, but we need to understand this. Next up, we are countering unknown devices. Not surprisingly, everyone uses their own device to connect to things within our networks, within our systems, within our apps. I think at ngrok, I'm one of the exceptions, and I don't have my email on my phone. I have Slack though, and frankly, it's freeing. But really, the important thing is that people have devices that they're connecting to things on our network, in our systems, and we need to understand that we can't trust those either. We don't know if they're up to date, how they're being managed, if they're rooted. We need to understand those or get a handle on those things. Next up, we're countering malicious apps, things outside our firewall, outside our network, outside our control, are trying to get access to what we have. They want to be able to leverage or collect and leverage the data we have. They want to get access to our systems to use them as launching points on attacks for other systems. They want to do all kinds of nefarious things. And next up, we are also protecting against malicious apps. And this is not a typo. When I say malicious apps here, I don't mean things outside our network. I mean things inside our network, because with the rise of supply chain attacks, when some underlying component of our system is compromised, it turns out our very apps themselves could be compromised. There have been a number of node libraries out there that have done Bitcoin mining and stuff like that. We need to be aware that this is a thing, this is happening. So even the apps that we deploy on our machines, can't trust those either. And that kind of sucks, because really it should. When I went looking for some additional data points on this yesterday, I mean, it's really easy to say this out loud. It's really easy to believe this is a hypothetical. But when you go around and you look for this in the wild, there was a system that went out. Let's see, this article is from, 13 days ago, November 3rd. So there is a adware malware attack that all it does is it pops up, or this was installed on 250 media websites, and this pushed fake Chrome, Explorer updates, Firefox updates to people's systems to try to get them to upgrade to a compromised version. This was live as of 2 weeks ago. Now, most people aren't going to fall for that. Especially this audience. This audience is tech savvy. They understand, don't do random updates. There's a process for that. It turns out, though, that we are bad at this too. Last night, I found this one. So a third of all Log4j downloads are still vulnerable. Now, this is an exciting one because the Log4j breach was, 2 years ago now? It's been quite a while ago. And at first I saw this and I said, oh, well, this is horrible news. This is really bad. That means that the Log4j getting deployed into our internal applications, into our log systems, into our reporting mechanism is likely compromised, or compromisable is probably a more reasonable way to put it. And I said, oh, well, this can't be a major problem. Now, after all, it's been a couple of years. And then I noticed the date on this. This article is about 48 hours old? About that. Everyone, this is a problem. Our applications themselves are working against us. We need to understand that, and we need to understand what the consequences of this are. And the consequences aren't good. So let's figure out how to solve this problem. You saw a variation of this diagram earlier from Jonas. This is fundamentally what most zero trust architectures are based on. We've got all of our individual components that live over here. We've got our policy engine in the middle that's collecting data, that's applying policy. He mentioned the policy enforcement point. Inside of this, there's also a policy decision point where it actually decides what the policy is and applies them. And the enforcement is the actual lockdown, firewall, gateway, whatever you want to call it there. That's where the policy is being applied to block or allow access between the subject and the resources. This is a great model. This works out really well. There's a couple gaps with it. Now, when we think about this, and obviously this is for zero trust, when we think about the root of zero trust, it comes down to our trust no one aspect. I would say that most people interpret this a little too small scoped. When most people say trust no one, they mean literally people. And I would expand that out a little bit. I would say trust nothing. We cannot trust anything. We can't trust our users. Some of them could be malicious. Some of them could be, frankly, a incompetent or even an accidental breach looks the same as a malicious breach in a lot of different ways. So we can't trust our users. We can't trust our devices. That phone may be rooted. That phone may have all kinds of those games that you think you're installing may not be games at some level. We need to think about when we trust nothing, the devices themselves can't be trusted and our apps themselves. When we think about pulling all this together and we go back to our zero trust principles, continuous verification is absolutely critical. We cannot get around that. Jonas talked about that great with the token-based architecture. We cannot avoid that. We must do that. Collecting and using context is absolutely vital. We need to understand what's normal on our network, what's normal in our interactions, and how service A uses service B, and how user A uses service B. We need to understand what's normal there. We need to be able to take action as a result of that. But I really want to focus on minimized impact. If we go on the assumption that all of our systems are going to have problems at some point, how do we minimize the impact of those? And so I would say, starting from the model that we had before, we need to shift this model just a bit. If you look at most zero trust architectures, they talk about having a centralized component to do this and having one place where all these decisions are made. That is fantastic from a policy, from a management standpoint. It's exceptionally powerful in that way. It's much easier to deploy and manage that. The problem is our architectures don't look like that. Our architectures are all over the place. When I was at Okta, the number they used to throw around is that even exclude the most cloud first companies, like exclude Twilio and Stripe and those guys, the next tier, roughly 30% of their architectures are in the cloud. The other 70% are living in data centers in different places. So while we would love to have one single place, one standardized expected place where all of this stuff lives, doesn't happen. It can't happen. Somebody mentioned earlier about the perimeter being gone. Yes, it absolutely is. If our perimeter is gone, then these centralized components fall apart pretty quickly. So I would say, instead of this model, let's shift it a little bit and let's put this model into every single component. Let's make sure every single system has the ability to understand this and make these decisions. Because what happens now is that every single system is responsible for itself. This gets back to that whole distributed nature of things. When every single system, when service A understands this is how people interact with me, this is what normal patterns do, our systems are going to be much more secure as a default. Now, we obviously need to aggregate this information up. We need to have a view, observability across the system. We need to understand, though, that just like in your organization, if you're in a big organization, the CEO says, I want to do X. A good CEO won't come to you and say, and it must be done like A, B, and C. A good CEO will lay out the direction of things, the layout of vision, and let the individual teams figure out what their vision, how to execute on that vision. And as long as they're going towards that in safe, secure, legal ways, fantastic. We need to think about that same distributed nature here so that each individual component can understand. Because when we have a system and it gets compromised, and it could be compromised by a malicious actor getting a breach into it, getting like live access to things. It could be a component somewhere in our supply chain that's been compromised. It could be not compromised in terms of a security state, but just compromised in sense of it's into a bad state. Maybe there was a bad deploy. There's a bad configuration that got deployed here. We need to think about this as not just from security, this is architecture in general. So something gets into a compromised state, whether it's a security situation, whether it's just a bad deploy somehow, a bad library somehow. We need to think about what we do with this. Now, just detecting it is not enough. We need to then figure out how to disconnect it from the other systems in our network and then remove it and make sure that it is no longer a player in our systems. We need to make sure that whatever is going on, we're not going to stop and diagnose it right then. We're going to remove it from the system first and then take action. Now, once that's removed, hopefully we've got a process in place that we can go ahead and we can replace it. And we've got automated deployment systems that can rebuild it, build it back up, deploy it again. Now, if we have a supply chain attack, we need to mitigate that. We need to understand what was the exact version of things that got deployed. Maybe we have to roll back a release, whatever. But we need to understand that our systems need to have these capabilities. They need to be able to be responsible for their own security configurations and their own components, and then remove themselves or be removed from our systems and then restored and replaced when the time is right. So this is a much more complicated model. I know it's kind of unfortunate. Like I said, zero trust is not zero effort. But the components need to have their own context. They need to understand what's normal for them, what's good behavior, what's bad behavior. And in some ways, they need to be able to sound the alarm. So they need their own policy enforcement points. So there's a lot of people that are doing the different micro gateways. Great model. I think that makes a lot of sense. I've seen some great things around people like Kong and Tyke. In fact, ngrok will do this. With some of our webhook verification and our security policies baked into the connection itself. So you get it on the connection itself instead of inside the component, which may be a good trade-off for you. Every component needs its own analysis and its own policies themselves. They need to understand this is what normal looks like. There's a number of systems that I use that when somebody does a massive download, it'll actually email the administrator saying, hey, user X just downloaded 2 million records. We need capabilities like that built into every single system so that when something happens, notice I said when, not if, when something happens, the alarms are set off and we can take action. I like to think of this as effectively a neighborhood watch. So if the components in your system, in your architecture, understand what normal is, when they see something that's not normal, they can send off an alarm. Maybe you take action on that alarm, maybe you don't, but at least you know something weird is going on here. And in some cases, you could say, okay, this is not weird. This is a new use case that we just hadn't seen before, but it's a totally reasonable, legitimate use case. But without that continuous flow of information and understanding and analyzing it, we're not going to get that. So a couple closing thoughts, and then we'll go ahead and wrap up, and I'll hand this back to Bill. So some questions asked. These are 4 questions that I always try to leave people with to understand how to do this, how to think about this well. We need to understand what components make up our app. And I mean these are the big components behind the scenes. So think of a database server, a web server, but it's also the APIs that we're dependent on. If we understand what those components are, we can make better decisions and understand things better. Next up, we need to understand what can connect to those components. Just because our database server looks like we're the only one interacting with it from our one app, we should probably double check that. We should probably understand what's communicating with it, what it can do, what services are putting additional load or moving data around on those systems. We need to understand that. The better we understand what can connect to these components, then we can either block them, we can figure out how to authenticate and authorize them properly. And in some cases, we may just want to lock things down even further. Those are all totally legitimate scenarios. Then we want to figure out what can those components connect to. Notice the first one was what can connect to those components. Now these are what can those components connect out to. A lot of times in a supply chain attack specifically, we have systems making calls out to other systems for command and control, for data exfiltration, for all those different things. We need to understand how are we securing this to make sure that the data that we have, the functionality that we have, is behaving the way we expect it to. If it's not, again, we need to set off those alarms. And I think my favorite one is we need to understand, do we have an emergency stop? In the States, whenever you stop and get gas, there's always that big red button on the gas station where if there's a problem out, among the gas pumps, somebody can go and hit that red button and all the pumps immediately stop. That's what we need to think about here. When something happens, how do we immediately stop everything? How do we stop that data exfiltration or that infiltration in progress right now? If we don't have a way of doing that, short of turning everything off, we might want to rethink things a little bit. So with that, thank you. Really enjoyed this. Hope this was useful for you. And now I'm going to hand it back to Bill. Please take it away.
Sweet. Thank you, Casey. Yeah, great presentation. I especially love hearing about the network layer and like the physical layer underneath, because I mean, being like API people, software people, usually that's not really our expertise or area where we discuss, but it's definitely valid. I love the story about hacking the client's network while on premise too. That's a little great nugget there.
It definitely was not hacking, even though it was unauthorized access.
Sure.
One thing I did leave out of that story is they said, what are you doing? How are you on our network? And I said, well, I'm making API calls, just like that guy sitting out in his car right there.
Right.
And everyone turned and looked. There wasn't anyone sitting out in the car right at that moment, but in theory, anyone could have been doing that at any point, and no one in the organization would have had any clue about it.
There could have been. Yeah, exactly. Yeah, because like what you've outlined, the network perimeter has been dissolving and mutating over time, from hardwired connections to Wi-Fi to bring your own device, and it's just super confusing mix. I assume like a lot of network engineers just don't have that communication with the software developers on like what is actually secured and what isn't.
Yes, and most likely we've built assumptions into our system based on what they're doing, and we never actually talked with them to confirm that.
Yeah.
And we need to understand that our assumptions may be true right now at this moment. It may be a reasonable assumption for right now, but 3 months, 6 months, 2 years from now, it may not be. And we just need to be prepared for that.
Would you both say that, like, with knowing that, that we need to kind of de-silo those two worlds a bit to get people more on the same picture to really have a holistic zero trust approach?
Yeah, I'd say absolutely. I think if we think of like DevOps done well, operations is plugged into development. It's one big org, it's one big motion to do things. And I think connectivity is absolutely a part of that. We took a very similar stance at ngrok, making sure that like the network is programmable underneath your applications. But I think just as a philosophical approach, we need to bake those things closer together.
Yeah, I mean, Keith's kind of hitting the nail on the head too with sort of the title, right? It's not zero effort. And that's the thing that I think needs to be remembered. It's not like, and Bill, you mentioned in your opening too, it's not like a single application. It's like, hey, I'll buy this component and then we have zero trust everywhere, right? There is a lot of effort in doing this. And I think in some ways, it's a little bit what paralyzes organizations too, right? It's like, where do I even start? Where do I begin? Because this is a pretty major shift in how you deal with things, right? So I think you need to get into sort of, you got to start small. You got to pick like one application and you got to start replicating that. And you got to start somewhere and you got to start small. You can't think of it as all right, let's do the zero trust project and just shift all of it. It's not going to fly. It's not going to work.
That was one of my questions here, like, where do you start? And I like what Keith was talking about like how every system should be responsible for itself. So maybe that's a natural way of like attempting this, you know, starting on a component by component basis and then expanding from there. Is that kind of what you guys would recommend here?
Yes, 100%. And I would start with generally with like the most critical systems. So critical defined as anything that touches money is probably critical. Anything that touches sensitive information, probably critical. And then third, anything that communicates with customers. That's probably a good thing to make sure, like, what are the common patterns here? What are good normal, what does good normal traffic look like, and what does bad things look like that we're going to block for now?
Right. Yeah. Jonas, any tips?
And when you start with those, when you start with those systems, you're going to end up with some level of recipe, right? That you can, to some degree, replicate for everything else, right? You kind of get the components and the pieces in place for those critical applications. It'll become easy. It's not going to be the same effort with application 1 that it is with application 15 or API 15, right? You'll learn along the way. You'll get the right tools in place to deal with it, and the further you go, all of a sudden it is going to start getting easier, right? It's still not going to get zero effort at application 15, but it's going to be a whole lot easier down the road. It's the beginning that's going to be hard for sure.
Yeah, the beginning is going to be painful. It's understanding what works here, not just in terms of practices and policies, but in terms of tooling. Once you do it 2 or 3 times and you've got that foundation, then rolling at some point it becomes just understanding what the policy is for component N.
Right. But yeah, at the same time, this seems like it could involve a lot of duplication and replication if we're placing this on a component by component basis. I mean, especially if a company is overseeing thousands of microservices and APIs, and like what's the scale we're talking about here? This does sound like a lot of effort. I know you already said it is, but I just want to hammer down that point.
Yeah, that's why I'm a big fan of continuous deployment, continuous integration, making sure that these things are baked into your pipeline, so that if you're using a API micro gateway or whatever, bake it into your deployment so that it goes out in every single node in your cluster, and you do it once for a class of services, and you don't have to think about it again.
Are there any worries about some of it like too bulky? Like these added layers of security protection?
I'd say there's a risk of that for sure. But I think there's sort of the tooling available has also not necessarily catered to this super well historically. I'm thinking sort of, and Keith, you actually kind of touched on a lot of that too, right? The entitlement management system, or the PDP, if we look at it from that core perspective, right? Historically, that's been a very centralized component, right? It's one PDP, all of the APIs, all of the applications need to use it. And that was sort of, it probably stemmed from the inherent model of sort of the perimeter security. It was okay to do it that way. Now it's not. And to Keith's point, like, you need to replicate that environment for essentially each application or API. And that's the challenge there, is probably lesser these days, because you have components like Open Policy Agent that caters really well towards, I'm an API, I have my own instance of my own PDP that's running. I mean, it can still run a global policy. The policy could span everything. It doesn't have to be its own. It'll have its unique subpart of the policy that's specific to that API or application, but it's not sort of that you have to manage the policy on an individual component basis necessarily as much. But you will have sort of your own instance of an authorization engine that I can leverage, that coupled with my application, my API, what have you. And I think sort of that model wasn't really all that accessible a couple of years ago.
Yeah, until recently. Like you said, Keith, like zero trust wasn't really invented as a concept until like midway throughout your career. So,
yeah, I mean, if you go into some of the
original,
original things, it's what, 6, 7, 8, maybe 10 years old if you're really kind and generous about it.
right.
But I think these principles, I mean, just look at how our industry as a whole is going. Things are becoming more distributed. I mean, with OAuth, with APIs, all these things this is the natural progression of things. The sooner we lean into that, the better we do it earlier.
I want to make sure we get some questions answered. Peter Millington offered a couple great questions here. Discussing zero trust and machine accounts and non-repudiation across complex enterprise architectures is a whole different level of complexity that I'm trying to deal with and come to grips with. Is there any information on these aspects that you guys can offer? Jonas, I know it was kind of offered during your talk. Maybe you could start here.
Yeah, I mean, it's machine accounts. It's not user accounts, right? So it's sort of, usually when you talk about authentication, the mind goes to a user, right? Because it's like a user entering a password or what have you. And I'm assuming this question is more related to sort of how do you identify a machine or a system, right? There's no user that you're authenticating. Well, within OAuth, there are ways to handle that. I'm thinking, like, straight out of my head, I'm thinking sort of certificate-based authentication of a system in itself.
Right.
That does go back though to Keith's point. It's not zero effort, because certificate-based authentication of systems, you kind of need a PKI, and that's not necessarily easy out of the gate. Although I'd say a lot of organizations typically have that in place. But yeah, you can authenticate a system based on certificates. You can even then kind of bind that system to the certificate. So I get sort of the technical term is a certificate bound token, right? So you get a token to a system that can only be used by that system. That's one aspect of that. And yeah, that's at a large scale, that will be complex. It'd be complex to set up, but if you have a good setup of a PKI, it should be at least alleviating that effort a little bit.
When we're trying to verify workloads, is this where Spiffy and Spire comes in, Jonas?
Yeah. Spiffy, Spire is definitely something. I'm not sort of an expert in that area at all, but yeah, Spiffy, Spire is sort of the go-to for handling and authenticating workloads.
Right.
It's doing a lot of sort of quick rotations of certificates and things of that nature. At Curity, we've done a little bit of that work with a customer.
Yeah, I've noticed a little bit of that. Yeah, Keith, any thoughts there?
Yeah, it's not easy. It's not easy. When we were first at Okta with like client credential flow, it's amazing how like just that process itself doesn't have a good way of like refreshing the client secret in a reasonable way. At ngrok, we've been digging into that with our mutual TLS support to be able to make that as part of the connection as opposed to part of the component itself. Functionally, it results in much the same thing. But we've kind of leveraged that to be able to simplify the management, to be able to not have to do it on like individual architectures and everything like that, because yeah, it's an absolute pain. But I think Jonas is 100% right. Like doing certificate-based flows back and forth is the way to do it, whether that's with mutual TLS or something else. As long as you've got the PKI infrastructure, or I mean, Let's Encrypt will do it now so easily. Like there's really no excuse to have that. And if it's internal network components anyway, you could probably use a self-signed cert without too much problem. Yeah, I think we're reaching the point where the tooling is fantastic. Leverage it whenever possible. And the first time it's going to be painful, because it's always painful the first time till you build up the muscle memory to do it well.
Right. Got another question here from Peter. And earlier, I like this question because earlier we were talking about the need to de-silo departments so that everyone is like more on the same page. And Peter's asking, federated security controls takes us back from the centralized model of security as a service. It means every team now needs top flight knowledge on security matters. So how would a large organization address this? Keith, you maybe want to kick this one off?
Yeah, absolutely. Yes, each team does need some top flight knowledge. I like the center of excellence model in general, especially for larger organizations. I was at Capital One doing this for their API design for a couple of years. Basically, you've got the overarching team. You've got a center of excellence that knows their stuff cold. They're drafting, they're putting together the policies for the organization as a whole. They're writing playbooks and understanding to make sure that understanding goes widespread. And then they're doing internal education, advocacy, whatever, to make sure those practices are followed. Now, that's not going to catch everything, but if you can catch the first 80, 90% just out of the gate that way, that's a good way to do it. Then you layer on top of that policies. So you make sure that you've got good audit control over the policies that are in place. If you do that well, then now you've got the individual team members doing a better job with it, which is great. You've got the policies as a backstop against them and to be able to support the infrastructure as a whole. And then the things that make it through that layer should be a much smaller, more specific set of issues and set of concerns. So now you have a much smaller surface area for attack, for vulnerability, for education. So I really recommend that's the model in general.
Great.
I'd add standards as a good thing. You know, so you don't have to reinvent the model or anything like it's. There's plenty of information out there, right? If you go with the standards-based approach, you can also level up that awareness of the team, right? With the knowledge, because it's been vetted for a long time. And when I say standards, I typically mean OAuth and OpenID Connect, but then SACML from an entitlement management system is one, and Open Policy Agent is not a standard, but it's it's a framework for handling it, and it's very common. But yeah, that's something that plays in there a lot.
Got it. Gordon King is offering a comment here saying TLS will be terminated by application gateway or other L7 middle box. I recommend that HTTPA or other application layer protocol would be more secure. Yeah, do you agree with this, or do you think there is a different like protocol that's more secure than TLS in this situation?
I recommend layers.
Layers, okay.
Yes, do it all. Like have the components layered together. I mean, if you look at the OSI model, it's all about the 7 layers and making sure things are secure and moving back and forth on all the layers. Do the exact same thing. Yeah, until you start introducing latency, it's probably not a problem.
Yeah, Jonas, any thoughts there?
I agree. Cool. I mean, it's one of my slides, multi-layered. There's different. You transport through the architecture. There's going to be different parts of that deals with different things, but in my mind, that is different layers. I mean, if you look at sort of a token-based architecture, the first layer is even issuing the token. Like I might not even be issued a token because of reason X, right? That's even the first. You don't even have that's outside the scope of how you're communicating with the API or application to begin with. Like that's layered. That's the first layer of that part. But Keith is also talking about the different layers in the technical stack, which also plays into that for sure.
Fantastic. Thank you both so much for your time today. I think I'm going to wrap it up here unless either of you would like to contribute any other lasting thoughts on Zero Trust.
Thank you.
Yeah, I think we're good.
It's all good. I mean, lasting thought would be get started.
Yeah, get started.
It's going to take a while, so get going. Yeah.
Awesome. Well, I'm just going to have some ending slides here. So thank you for everyone who tuned in live or is watching on YouTube here. It's been a live cast from Nordic APIs and a few updates. we will have some event announcements coming soon, so check our call for speakers. And if you'd like to participate yourself in one of these livecast events, you can submit there your talk. And if you love APIs or related thoughts around APIs, our blog is open to contributions from the community, and you can learn more about that at nordicapis.com/createwithus. And I also like to remind viewers that I operate this bi-weekly newsletter. We put in a lot of great tidbits from the blog and elsewhere. So sign up for that if you'd like a little bit of API knowledge in your email inbox. And lastly, thanks so much to our sponsor, Curity. You can learn more about their OAuth server and identity and access management tools at curity.io. So that's all for this one.